Electric bikes, scooters, and skateboards have all become commonplace as economical transportation solutions for commuters. So why not electric rollerblades? Good afternoon, we are Teammate and we present to you Ebladez, the electric rollerblade upgrade. Our goal with this product is to create a lightweight alternative method of transportation for commuters and rollerbladers, allowing users to traverse small hills and cover large distances with relatively minimal effort. Ebladez are motorized attachments for rollerblades comprised of a system of engineered components which can be compatible with a variety of rollerblades. Other popular electric vehicles such as electric skateboards, bikes, and scooters are often heavy, expensive, and difficult to store. For example, bikes and scooters are generally too large to be brought indoors and may be subject to theft when locked outside. Comparatively, rollerblades are much lighter and more convenient to transport and to store. To develop this product, we began with a set of functional requirements as our target and optimized our design to meet them. To meet our expectations, the Ebladez module needed to be able to attain a top speed of at least 20 km per hour, accelerate to this speed in 20 seconds, and have a range of approximately 10 km on level ground. We also wanted to be able to climb hills with a gradient of about 5% and do all of this while keeping the product weight below 5 kilograms. Before we demonstrate the capabilities of our final product, we would like to establish some safety precautions. As with any sport, there are risks associated with using Ebladez. Severe injury may occur if the product is used incorrectly. We strongly recommend that any user of Ebladez should have ample skating experience and feel comfortable on standard rollerblades. Furthermore, adequate safety gear is required. This includes gloves, knees, and elbow guards, and a full helmet. Please contact your doctor to find out if Ebladez are right for you. Our final design consists of a geared drivetrain system involving the use of a 3D printed rollerblade wheel, a custom designed battery management system or BMS, a battery pack, and a 3D printed enclosure. These components make up a single Ebladez module. We wanted to keep all the electronics inside of a 3D printed enclosure to help keep them secure and have a more compact design. There are three main parts to our electronics enclosure: the battery cell racks, the battery enclosure, and the BMS enclosure. The BMS enclosure consists of two parts, the base and the lid. The base slots into and over the battery enclosure, and the lid slots into the base. 3 screws go through the lid, base, and into the battery enclosure to create compression on the battery packs and provide a tight fit. This enclosure houses the BMS and all the other electronics and wires that feed into the BMS from the ESC and the batteries. The battery enclosure houses the 2 cell racks and has a slot along the side to house the electronic speed controller, or the ESC. The enclosure has a large cupped side that allows for the battery enclosure to fit tightly to the rollerblade boot on a variety of sizes. It also has loops on the outside to allow for Velcro or shoelaces to wrap around the front of the boot to support and secure the enclosure. There are 2 battery cell racks that each hold 10 18650 lithium-ion cells. These supply energy needed for the motor. They are arranged with 2 parallel 10-cell series that provide the power needed to run our motor at our desired speed, while maintaining a longer charge than if we only used 1 line of 10 cells in series. The cell racks are designed to house the batteries while also allowing for our connecting wires to run the length of the enclosure without any interruptions. Moving on to the drivetrain. The drivetrain system went through several major iterations. In the end, the decision was made to proceed with the belt-driven system for its high torque and reliability. The mounting brackets for the drivetrain system are 3D printed out of PETG in order to ensure structural toughness and rigidity while experiencing high torque from the motor and drivetrain. It also supports the large electronics case, so it is crucial for this component to be reliable. The main shape is formed around the boot of the rollerblade to keep stress concentrations low and features multiple mounting points for the motor and connecting rods. The mounts that connect the existing wheel bolt holes on the rollerblades are adjustable, which allows for correct fitment over a wide range of different rollerblade models. In addition, ensuring the correct drive belt tensions for the rollerblades. The drive system also involves a custom rollerblade wheel which integrates the driven pulley in the center of the wheel. The core of the wheel is printed from solid PLA to withstand the forces applied by the belt. The outer part of the wheel fits tight on the core and is printed with TPU, or thermoplastic polyurethane, which is a slightly flexible filament that most resembles the cast urethane of standard rollerblade wheels. After some testing, we found that the optimal print settings involved a high parameter count and a high structural infill percentage. Ultimately, this drive system can be modified to adapt to most sets of rollerblades, allowing individuals to electrify their existing pair. In an attempt to increase reliability, safety, and eventually reduce market cost of this product, we designed a custom battery management system, or BMS, to manage the lithium-ion cells. Compared to off-the-shelf components, our BMS integrates many safety features, such as a current overload protection and temperature sensing for each one of the battery segments. When overloaded, lithium-ion batteries can combust and cause thermal runaway, expanding to other cells in the segment. To achieve this, we use a specialized chip that monitors the voltage levels and then an ARM-based microcontroller to perform logic and charge individual cells. This accounts for the slight deviances that each cell may have in charging and discharging, which results in voltage differences. We integrated many ease-of-use factors, such as reducing the amount of wiring, having LED readouts for the percent of battery left, and having input and output pins for future expandability, like more switches and dials. Looking back at our functional requirements, our design met all of our requirements. Using only one powered boot, we were able to accelerate to 20 km per hour in 10 seconds. This time could be improved with the addition of a second powered boot, but we are satisfied with our performance thus far. The hill climbing limit of this prototype is currently a 5% gradient, which is satisfactory. To test this range, we took the boot to UBC and rode up and down the pathway beside the fields. A full charge, we estimate that the range on flat ground is 20 kilometers. The total weight of the Ebladez module is about 2 kilograms, which exceeds our expectations. Ultimately, there are some improvements to be made to this design. After testing, we realized that the added weight of the Ebladez module on a single boot made skating feel unbalanced and awkward. This could either be remedied by adding a second Ebladez module or further reducing the weight of a single module. The latter option would cut down on battery size or motor size, which would reduce performance, but this may be more optimal depending on the user's preference. Another improvement that would greatly improve user experience will be to optimize the installation process. As it stands, it takes an individual approximately 10 minutes to install the module. Ideally, this should take no more than 5 minutes. Due to time constraints, we were unable to prototype multiple modules to fit on different shaped rollerblades, but in theory, it would only take minor modifications to the CAD models to allow the prototype to work with any existing rollerblade. This concludes our presentation. If you are interested in our product or would like to purchase your own, please contact us at ubcebladez@gmail.com. Thank you for watching.